Hi, welcome to your lesson on an introduction to functions. We are going to have some fun with functions. Please get your notebook ready. Whenever you watch a video like this, it is expected that you take some notes, which I will be looking for in your notebook the day after as homework. Thank you. What we're going to talk about is a big idea in mathematics. Let's begin with some important definitions. First, relation. A relation is a relationship between input values and output values. More commonly, you are maybe accustomed to input values being your x values and your output values being your y values. Next, we have the domain. This is the set of input values, or in other words, very commonly, the set of x values. Then we have the range. This is the set of all output values. In other words, typically the y values. Now we'll define a function. A function is a specific type of relation where there is only one output for each input. In other words, each x value only produces one y value. Notice a function is a type of relation. That means there can be other types of relations which are not functions. All right, here are 4 different ways to represent a relation or a function. In this case, these are relations because some of them are not functions. So one way to represent them, or the first 3 ways, are ways you're definitely familiar with. There are ordered pairs. In other words, they're like coordinates. So we see the first one is -2, 2. That just means the x value or input is -2, and the output or y value is 2. So ordered pairs are one way. The second way to represent relations is through a table. Here we have an xy table. So the values are exactly the same as you see in the ordered pairs. The coordinates are now in a table format. Another way to represent relations is through a graph. Again, we've taken the same 4 pairs of points and plotted them on this graph. Finally, a way that you may or may not have seen, might be new to you, is called a mapping diagram. Here we see the inputs and the outputs. The inputs have arrows pointing to the outputs. This is called mapping. So for example, from the input -2, we have 2 arrows going to -2 and 2. The reason for that is that the input -2 produces both of those outputs. If we look back at the ordered pairs, we have 2 coordinates where there was a -2 x value, but there is a different y value for each one. There are 2 separate points. In here, in the mapping diagram, we don't have to list it as 2 separate points. We just do 2 arrows to represent the 2 possible outputs or y values. Let's look at the next one there, is 0, and the arrow goes to 1. Again, look at your ordered pair. There's a point 0, 1. Finally, we have 3 with an arrow to 1 as well. So the input 3 produces an output of 1. It is important to know that the last one there is not a function because 2 inputs, 0 and 3, produce the same output, which is 1. So now try one. So add this to your notes. You're given a relation as a set of ordered pairs, and you have those 5 points given to you. Now you have to represent this as a table, a graph, and a mapping diagram. And so refer to your notes from the previous slide for that. And at the end, once you've drawn all 3 representations, also give the domain and range. So pause the video now and get that done. Thank you. All right, next part of our notes here. Yeah, let's figure out which of these mapping diagrams represent a function and which do not. So the first one, we look at it. We have those 5 inputs and there's a bunch of outputs. If we look at it closely, remember the definition of a function is each input produces only one output. But in this case, you will notice the 3 input produces 2 different outputs. It produces a 3 and a 5. There's 2 arrows from the 3. So if 2 outputs are produced by one input, that is not a function. So this is a relation, but it's not a function because 2 outputs from 1 input. Look at the second one. Follow all the arrows. looking for the same thing. Is there any input that produces two outputs? All right, if you look closely, it may look like the first one, but it's not. You see an arrow from the 4 going to 4 and an arrow from the 5 going to 4 as well. So it seems to be that there's two outputs, but it's not. It's actually two inputs produce one output. That is okay. That is still a function. So make sure you understand how that one is different from the one on the left side. In this case, every input still produces only one output. So it is a relation and a function. There's one output for each input. So now, see if you can do this one. Take a moment. Look at the first one. Is it a function? It is. It's a function, a relation, and a function. Again, there's only one output for each input. Look at the second one. Hopefully you're thinking it is not a function, so it's only a relation. Because the one input produces two different outputs. There are two arrows that go from the one to two different outputs. So it's a relation only. All right, so now again, try it again. Quickly sketch these mapping diagrams in your notes and see if you can answer whether it's a relation or a relation and a function. On the bottom, do the same thing. You're given ordered pairs, and now use the same kind of thinking as the mapping diagram in your head. Can you figure out which one is a function, which one is a relation? Now we're going to talk about something called the vertical line test. The vertical line test is a way to check if data is a function on a graph. So let's take a look at this. I'm going to slide this blue line across. That is called the vertical line test for this reason. This is a vertical line. Now, the blue line represents one input. For example, when I go right here, the blue line is now at x value of 2. So everything along the blue line are all my outputs for the value 2. So if I follow the line up, go up to 2, and you're like, when x is 2, it produces a y value of 2 because there's a point right there. So there's only one output for that value of 2. But if I go back to 1, now the input is 1. But there are 2 points produced at the input of 1. There's a y value of 1 and a y value of 2 produced. So there are 2 outputs for the one input, which was 1. So this is not a function. It fails the vertical line test. Basically, that's how you do the vertical line test. You move a kind of an imaginary line or your pencil or whatever you need across your graph, and if it ever hits 2 points at one time like that, it means there's 2 outputs, therefore it is not a function. So this first one is not a function. Let's look at the second one. Does that vertical line ever hit 2 points at one time? Doesn't look like it. It only hits 1 point each time. That means for each of those x values, there's only one y value produced. One output for each input. So that one is a function. So look at these two. First one is a parabola. Quadratic equation has been graphed. Notice there's a vertical line there, the red line. So imagine moving that red line across your parabola back and forth, side to side. Does it ever hit the parabola twice? No, it will only hit once every time. So a parabola is a function. Look at the second one. It's kind of a parabola. It's a horizontal parabola, which has a different equation. Instead of y equals x squared, it's x equals y squared. That one, if you look at the vertical line, the red line, it hits that parabola twice, right here and right here. Therefore, that relation is not a function. There are 2 outputs, 2 y values for that one x value. Let's look at a more real example, or maybe not so real because it's kind of old, but it's still real. Kevin Garnett did once play in the NBA. So let's look at Kevin Garnett's, his age versus average points. So if you look at this one here, imagine dragging a, oh sorry, that's not for him, that's for the whole Timberwolves team, that's the team he played for. Imagine dragging a vertical line across this graph. At 28, which I'm going across now, at the age of 28, a vertical line would hit right here and right here. So this data is not a function, it's just a relation. And let's look at just Kevin Garnett now. So his age and the average points he scored per game. So notice as he played, he scored more points per game. But more importantly, if you take a vertical line and drag it across here, it'll never hit a point more than once. So that is a function. That makes sense because for a whole team, there may be two players that have two different averages at one age. So two players are age 28, but they each have a different average. But for just one player, there's no way at one age he can have two averages because that one player can only have one average for that age when he was that old. All right, so that's about it. We have one more slide. Take a look at this last one. Last thing for you to try, looking at these four, use the vertical line test and decide if each of these is a function or not. All right, we'll come back to the ones that you're supposed to try as our beginning to our lesson tomorrow. Make sure you've tried them out and understand this concept. See you soon.